This is liquid nitrogen. This is a superconductor. And this is a track of magnets. When I dip this superconductor into the liquid nitrogen and then place it on top of this magnetic track, something special happens. It levitates. Imagine what you could do with this technology. Some people have used it to create a hovering skateboard. Or how about a hovering train, getting you to your destination faster and using less energy? Or maybe a hovering car. There are many potential applications of this technology, from storing energy to power cables. But the problem is, it's difficult to implement in real life. Why? Well, one of the reasons is because we need to cool down this superconductor to minus 181 degrees Celsius. But imagine if we could create a superconductor that doesn't need to be cooled down, that could work at room temperature and room pressure. This might be possible if we could understand how the atoms in this superconductor behave. The problem is that the world's best computer does not have the power to understand this. A quantum computer could change that. A quantum computer is a fundamentally new type of computer that uses quantum physics. Everything in this world is made up of atoms, and quantum physics describes how those atoms behave. Therefore, we could potentially understand how the atoms in the superconductor behave, and that could give us insight into creating a superconductor that could work at room temperatures and pressures. Therefore, quantum computing could unlock the amazing applications of this superconductor technology. The first time that I saw this superconductor experiment was in 2009, when I was 13 years old. My school got invited to a technology event at the local Microsoft offices in Reading in the UK. I remember walking into a room and there were all sorts of crazy experiments on display. This is a picture from the actual event. There were explosions, liquid nitrogen, superconductors. It was incredible. And I remember the speaker, Chris Bishop, the one in the green shirt, describing quantum physics. And I vividly remember his description, and it seemed out of this world, but it describes how the world works. That was the spark that led me to study physics and computer science at university, where I started the Harvard College and Stanford Quantum Computing Associations. Now I am doing my PhD in physics at the University of Oxford, specializing in quantum computing. Over the years, from the time that this picture was taken till now, I've seen the amazing evolution of quantum computing, and that's why I believe that quantum computing could transform our world. It's because of the potential of quantum computing that we have discovered. It's because of the power of quantum computing that we have uncovered. It's because of the progress of significant achievements that we have ushered. Let's understand how these three elements could lead to quantum computing transforming our world. First, what could we do with a quantum computer that we can't do with a normal computer? To illustrate such an example, I have this bag. Inside, I'm going to put 4 balls. 3 of them are white. 1, 2, 3. And 1 of them is blue. Then I'm going to close it, shake it up so that it's random. And then let's say I'm searching for the blue ball. Well, I could open it up, pick out a ball, and check whether it's blue. And then I will continue until I find the blue ball. This is how your normal computer solves such a problem. If we had 4 balls, it would take a maximum of 4 tries, since you might get the blue ball on your last try. But what if this were a quantum computer? Even if I put all 4 balls inside this bag, with a quantum computer, you could get the blue ball on the first try every single time. So a quantum computer could speed up this process from 4 tries to 1 try. And in general, quantum computing can speed up searching when there is no structure. This example is called Grover's search. And there are other processes that quantum computing can speed up. And when I mean speed up, I really mean speed up. For example, there are certain processes that could take billions of years to solve on our normal computers because you have to search through so many possibilities. A quantum computer could do this in just seconds. And this is why it's so exciting. Things that are practically impossible to solve today could be made possible with a quantum computer. And this could transform industries. For example, in medicine, you want to find a new medicine, and that process can take some time as you have to search through a lot of different possibilities. A quantum computer could speed this up, allowing us to find new medicines that could cure some diseases. Or how about a vaccine? We're all familiar with the time frame it takes to develop a vaccine. Well, a quantum computer could potentially help us find a vaccine faster. Or what about in material science? You want to create new materials that could make the phone and the laptop you use lighter and stronger. Well, a quantum computer could do this. And how about artificial intelligence? We've made more progress in AI now because of the more powerful computers we have today compared to many years ago. In a similar way, a quantum computer could advance artificial intelligence. As you can see, there's so many applications of quantum computing, from finance to space to logistics. We could solve today's unsolved problems with quantum computing, which could transform our world. So how are we able to do all of this? Well, this is because of the power of quantum computing that we have uncovered. Now, in order to understand this power, we have to understand a little bit about how our normal computers work. Let's say you're typing up an email to your friend. Hey, smiley face. What is your computer doing when you do that? Well, you may speak English, but your computer speaks the language of binary. The English alphabet is A to Z, but the binary alphabet is just 0 and 1. So anything you type is translated to a sequence of zeros and ones. For example, this H is translated to these sequence of zeros and ones. And you can do this for E, Y, smiley face. And your computer does this for everything that you do on it. It always translates it to zeros and ones. Now, to illustrate this, which is called the bit, I have this donut. Let's say the plain side is equivalent to 0 and the frosted side is equivalent to 1. This is called the classical bit. It's called a classical bit because it's used on our classical computers. And a classical computer is basically a normal computer. Now, what about a quantum computer? A quantum computer also has sort of bits, but they're different. We call them, creatively, quantum bits, also known as qubits. And a qubit can be 0 and it can be 1, but it has access to something special. It has access to quantum physics, which means it can behave in a quantum way. For example, it can be a combination of 0 and 1. I think of it like this spinning donut. Now, it's a combination. And this is called superposition. How powerful is superposition? Let's say you have 300 qubits in superposition. How many classical bits would you need to represent this? This number. That's 10 to the power of 90. This number is so large, it's more than the number of atoms in the observable universe. So as you can see, superposition and other quantum effects make our quantum computers powerful. So how do we put our qubit into superposition? We use something called quantum gates. Quantum gates change how our qubit behaves. For example, we have this Hadamard gate. So this Hadamard gate takes our bit as 0, we put it through the gate, and now it ends up in superposition. Remember I showed this example with the 4 balls and how you could find the blue ball in one try? Well, the reason the quantum computer could do this is because you put all of the balls in superposition. And the way you do that is through the Hadamard gate. Let's say you're baking a cake. You might use a recipe. The recipe tells you instructions on how to use the tools you have to change the ingredients so that you end up getting your cake. Well, a quantum algorithm is a set of instructions that we give to a quantum computer. So the quantum algorithm is like the recipe. The tools that we're using are like the quantum gates, and the qubits are like the ingredients. So a quantum algorithm tells you how to apply the quantum gates, so that you change the qubits so that you get your desired solution. So how much progress have we made in quantum computing? I've talked about all of the amazing applications in the power, but how much progress have we actually made? Well, there have been significant achievements that we have ushered. Computers used to be only accessible to scientists, but there was a big shift in the 1970s, and that's when computers became available for everyone to use in their own home. Now, these computers were limited and you couldn't do many things with them because they were not so powerful, but people played around with them. And as they did, that transformed the industry. Well, people think that quantum computers do not exist or that they're only accessible by scientists. No, that shift has occurred. In 2016, quantum computers became available for everyone to use, and you don't even need to buy one. You can just use it for free through the internet. Now, these quantum computers are limited. There are a limited number of things you can do with them. They're not very powerful, but as people play around with them, that could help the field progress. So let's take a sneak peek at how you use a quantum computer. You can use the IBM Quantum Experience. When you go to this platform, you see that there are these different lines. These correspond to each qubit. And now you can also see the quantum gates. So these are the different tools that we can apply to the qubits to get our desired solution. So for example, if I want to put my qubit into superposition, I can drag this Hadamard gate onto the first line, which corresponds to the first qubit, and then I can click Run, and it can run on a real quantum computer. Now, this is a simple example, but there are more complicated things you can do with a quantum computer. For example, you could play quantum chess, you could do machine learning, you can find the optimal path for a bus. And one of the reasons this is possible is because of the progress that we've made in the hardware. Now, in order to understand the progress in the hardware, I'm going to visit the LEAK lab at the University of Oxford. They're building quantum computers for commercial quantum computing by their spin-out company, Oxford Quantum Circuits. And they were kind to let me take a look at their lab. This is the LEAK lab. Now, you might be able to hear some of the background noise. This is the noise of the fridges cooling down the quantum computers. At the beginning of this talk, I showed the superconductor that needed to be dipped in liquid nitrogen so that it was cooled down so it could work. Well, it's similar here, because here they're using superconductors for their quantum computers, so they need to cool them down in order for them to work. In my hand, I'm holding 4 real qubits made out of superconductors. You can even see the qubits with your naked eye, and if you look close enough, this one actually has the shape of a donut. But not all qubits are made like this, so they do not all look like this. So these qubits are placed at the bottom of this fridge. When I run something on the IBM Quantum Experience or use any quantum computer, the instructions I send, the quantum gates, are sent to the quantum computer, similar to this one, through the internet. And then the instructions are sent all the way down to this fridge. They apply the gates to the qubits, and then we get the result back to us. Incredible. And we've made so much progress in the hardware. About 5 years ago, we only had 5 qubits, but now we have around 53 qubits and more. And 53 qubits allowed us to achieve a significant milestone in the field in 2019. This was the first time that an actual quantum computer could outperform the world's best supercomputer. Google constructed a problem and then they ran it on their quantum device, and it took about 200 seconds. Then they estimated how long would this take on the world's best supercomputer. 10,000 years. Amazing. But the thing is that this is for a problem that is constructed, so it doesn't have real-world applications yet. So the next milestone is to do this experiment, outperform a normal computer for a real-world application. And this is called quantum advantage. Quantum advantage could transform this world, and you could be a part of it. If you're in the industry, you could work with quantum computing companies to find potential applications in your industry. If you're interested in the power and how quantum computing works, you can actually run your algorithms and applications on real quantum computers. And if you're in the quantum computing industry, you could educate the future workforce of people that will contribute to the progress of this field. As people unlock new applications, play with quantum computers, and build a quantum ecosystem, quantum computing becomes more likely to live up to its potential and beyond. Then it is only a matter of time until it turns our world upside down. Thank you.